Everybody. In this section, we are going to talk about something called optimization. Actually, we'll do that in this section and in the next section. So we've been talking in chapter 3 about how we can use the derivative to tell us some useful information about a function. We talked about, for one, how the first derivative can tell us where a function's increasing, decreasing, where it's got a maximum and where it's got a minimum. Then in 3.3, we looked at how the second derivative can tell us about the bending of a function or its concavity. We also talked about how the second derivative can tell us how the rate of change is changing, whether something's getting steeper or less steep. So in 3.5 and 3.4, excuse me, we're going to actually swap these two sections. We're going to do them in reverse because they are both related in that they talk about the same idea. But section 3.5 is a little bit easier to manage, and so I think it's a better place to start. So with optimization, it's kind of exactly what it sounds like when you want to optimize something, which is what a lot of humans tend to want to do without even really thinking about it. You want to optimize your time spent doing something. Maybe you want to optimize your distance traveled. In that case, you'd be like traveling the minimum distance. Or maybe you want to maximize like your use out of something, like you want to, I don't know, maximize your score on an exam or something like that. Just finding the maximum and minimum of something is really what optimizing means. So we're going to look in section 3.5 at optimizing in an economics sense. So before we do that, in case you'd like a review of all of the economics terms and formulas, I'm just going to review that with you. So we have a lot of different letters that we use for different things, but in this class and in this economics context, we need to make sure that we understand what each thing means. So X we always use to represent the number of items or the number of things that we are selling or making or whatever. So it's be different in different situations, but X always means number of things, if not specified as it meaning something else. Then we have a lowercase p. This is the price for one item. This is what the customer pays for one item. So I'll just write customer. Right, price and cost sound similar because they're both with money, but price goes with how much the customer pays. Then we have related to X and little p, something called revenue. So that's capital R. Revenue is the money collected by the producer or the maker or the seller for selling X number of things. So revenue for selling X items. Okay, this is also a money quantity, but this is for the seller. Right, it's money that goes with the seller. So we have a formula for revenue. Revenue is always equal to the number of things sold times the price for one thing. So X times P. Okay, so this is a formula that is always true. Revenue equals X times P. Then we have cost, capital C. So this is the cost for making X items. Okay, this is the money spent by the seller to create a certain number of items. Then the seller also has something called profit. We use capital P for that. And this is also dependent on X, so it's the profit for making and selling X items. And again, this goes with the seller because the seller is who is making the profit. We have a formula for profit that is always true as well. Profit is always the money collected, which is revenue, and then take away the money spent, which is cost. And whatever's left over, that's what we call profit. So here's a formula for profit, revenue minus cost. So this is all old stuff that we've been talking about for the whole semester. Here's a new one. This is C bar, C with a bar over it. When we use a bar over something in math, sometimes with a decimal, it's used to mean something repeats in a pattern, but we can also use a bar over a variable or a letter to indicate average. Like X bar means the mean in stats. So C bar is the average cost. The average cost for making X items. And again, this also goes with the seller because cost is associated with the seller. So what's the difference between cost and average cost? Well, you might remember that cost can be thought of as a fixed cost plus a variable cost times the number of items, so times X. Fixed costs are things that don't depend on how many items you make. Variable cost is the cost for making just exactly one thing. So the average cost, what that does is it takes your fixed cost and kind of distributes it throughout all of the items that you make. So it can kind of just see on average what does one item actually cost to make if you include its share of the fixed cost in there. Okay, so a formula for C bar is just taking your total cost and then dividing that by the number of items made. So that's C bar equals C divided by X. So that's what we call average cost. So those are all of our variables. We also talked about their derivatives, which we call marginal revenue, marginal cost, marginal profit. So dr dx, or r prime, this is what we call marginal revenue. It is the change in revenue for selling one more item. So it's how much your revenue changes if you sell one more thing. dc dx, or c prime, okay, this is marginal cost. This is how much your cost will change if you make one more additional item. Then we have dp dx, d capital P dx, or capital P prime. This is marginal profit. And this is how much the profit will increase or decrease by if you sell one additional item. Now, in terms of optimizing things, we normally want to maximize certain things, so maximize revenue or maximize profit. And we want to minimize other things, like minimize cost or minimize average cost. So the idea with the optimization in these contexts is that we're going to find the maximum or the minimum of each of these things, depending on the situation. And these occur when the marginal, the derivative, changes sign. Okay, and we know that in our function world, context of just graphs or functions, right, the maximum or minimum occurs when we have a critical number. We make a sign chart and we see the function turns around, right? The derivative is positive then negative, or negative then positive. We would have a max or a min at those places.